So an operation is defined on a set of real numbers by x operation y equals to x plus y minus 2xy. If the identity element is 0, find the inverse of the element p under this. So we need to set up our expression to find the inverse element. So we're saying, in this case, p operation will symbolize the inverse element as this p prime. Okay, and it should be commutative. Okay, so we're trying to find the inverse element for p. The inverse element for p we are represented as p prime. Okay, and it should be commutative, and all of that should give you the identity element for that set. Okay, so the p we're trying to find the inverse element for p is p prime, and she equals to p prime operation p is equals to the identity element symbolized by e. Okay, all right, so let's blow through it now. So we have this our rule x plus y minus 2xy. Okay, and so we have p operation, its inverse commutative equals to identity. So we have p operation is inverse, the inverse of p is equals to, now we're applying the rule x plus y minus 2xy. Remember, x will be x replaced by p and y replaced by p inverse. So p plus p inverse, okay, p plus p inverse minus 2 times p inverse, 2 times p inverse. All of that equals to the identity element. Equals to identity. The identity element is given as 0 from the question. The question says, if the identity element is 0, find the inverse of the element p under the operation. So that's what we are doing right now. So we've replaced our, okay, we have applying the rule, we've replaced x and y with p and p inverse. So let's simplify. We have 2 times p inverse will give us this, okay, p plus p inverse equals to 0, okay? Okay, so this is p plus p, all of this equals to 0. This 2 times p inverse is like this. Remember, multiplication can join expressions, join the letters together. So it looks something like this. So we have p plus p inverse minus 2p p inverse equals to 0. So we can take p the other side, take p, collect p, can subtract p from both sides, So or in graphical, just move p this way. So it becomes 0 minus p, which is minus p. And then we see the p inverse. P inverse is a common term, so we can factorize p inverse out. So p inverse, factorize p inverse out, so it becomes p inverse 1 minus 2p. Okay, because if you expand this, you get this back. So we factorize, all of that equals to minus p on the left hand side. Now to find p inverse, divide both sides by what is inside the bracket, 1 minus 2p. So divide both sides by 1 minus 2p, get this as p inverse. Okay, so we found our, okay, so what we did was to factorize. P inverse is common in these two expressions, so factorize it out. So p inverse into itself is 1, p inverse into 2p, p inverse is minus 2p.